Welcome to a video on complex trinomial factoring. Technically it's trial and error factoring, but I call it the crisscross method, just of the way that you would crisscross to get things to work. So you start off by listing factors of the first term and the last term. So 2x squared could be split off into 2x and 1x. In the future I'll just use numbers because this is just rough work. 3 could be split off into a 3 with 1. I will also record 1 on top and 3 on the bottom, just in case the first combination doesn't work. So we crisscross multiply and add the result so that you can get the middle term. So let's try this. 2x times 1 is 2x. 1x times 3 is 3x. When we add 2x and 3x, we get 5x, not 7x. So we try the next combination. 2x times 3 is 6x, and 1x times 1 is 1x. So 6x and 1x is 7x that we want. So I will circle it so I don't forget that this is the one that I want to record. When you record, however, please record top with the top together and bottom with the bottom together. You crisscross only when you're looking for the combinations that work. When you record, you do a cross. So the factors of this polynomial are 2x plus 1 because it's positive 1 and x plus 3. Always double check that your work is correct by foiling things, especially the outer and the inner term. So outer is 6x and this is 1x, so that's exactly the 7x that we want. Okay, so let's try the next combination. So listing of combinations for 56, there's a lot of numbers that go into that. I always like to start for the numbers that are closer together, so 7 and 8. There's also 4 and 14 that multiply to 56, and 2 and 28, but I won't list them until I really need them. On the other one, we have -2. So to get a -2, we need one negative and one positive. I'm not going to record a negative until I know where to place it. So I'm going to just put in 1 and 2, or maybe 2 and 1, and I just want to think about the fact that there is one negative somewhere. Okay, so let's do the crisscross. And if none of the combinations that I have so far on this work, then I'm going to try a different combination instead of 7 and 8 here, because there's other possibilities. So let's try 7 times 2, that would be 14, and then we have an 8. If there is one negative, as we said, we're looking for the difference instead of adding to a -9. So 14 and 8 won't give me a difference of -9, so I'm going to try the other combination. We have 7 and 16. 7 and 16, if I have -16, I will have the -9 that I want. So I'm going to circle 7 and 8, 2 with 1, and I'm going to make the 2 a negative because we want the -16. So final answer, don't forget the x's. We'll have 7x minus 2, and recording top with the top and bottom with the bottom separately. So we have 8x plus 1. It's always best practice to double check before you begin that there is no greatest common factor, so that you have smaller numbers to work with. So in here we have all even numbers, so everything divides by 2. So I'm going to pull out 2. I'll have 3x squared plus 5x minus 2. And now we list off combinations for the first term and the last term. So first term has 3 and 1. And the last term is 2 with 1 or 1 with 2. So the last terms, one of them is again a negative. So I'll decide that later. So let's crisscross. 3 times 1 is 3. 1 times 2 is 2. So 3 and 2, don't rush and say that's a 5, because remember how we said 1 is negative? So it's actually not going to work. So we're going to try the next one. We have 3 times 2, that's 6. And then 1. So we want to have 6 minus 1 to give us this 5. So I'm going to circle the last combination here, and I'm going to make a negative on the 1 so that I have a positive 6 minus 1. So final answer, don't forget to record the 2 in the front that we common factored beforehand. And then 3x minus 1 as one bracket, and x plus 2 as the second one. Once again, another question, we want to see if there's anything in common. There is a 2, so let's pull that out. And then you may recognize this as a perfect square trinomial. Why I like the crisscross method is that you just remember one method and it works all the time. So you could still do factors of a squared, or 1 in front of it. It's just a 1 and 1. And of 9 is 3 and 3. There's also other combinations here, and 1 and 9 would work too, but I always try the numbers that are closer together, as I said. So this one you crisscross and multiply, and then add the results, you do get the 6. So as you could tell, that it is a perfect square trinomial. So it would be a plus 3. Instead of writing it twice, I'll just write down a little square on there. Okay, in our next question, we have again a common factor. So we pull out the 2. We have 6c squared minus 13c minus 8. Listing off factors of 6, we have 6 and 1, or 2 and 3. 8 is 4 and 2, or 2 with 4, or 8 with 1, or 1 with 8. Okay, so again, there is one negative here, so when we crisscross, we're actually thinking subtraction to get the negative 13. All right, so let's try some combinations. This would be 16, and that would be a 3. Oh, look at that, we had it right on the first try. So we have negative 16 plus 3 would give us negative 13. So I'll circle that. And the negative has to go on the 8 to create the negative 16 that we want. So equals 2. And then we have 2c plus 1 and 3c minus 8. This other example may remind you of perfect square trinomial, because this is a perfect square and that one is a perfect square, just like we had up here. But the middle term actually is not what you want, and it's easily seen if you proceed with the crisscross method once again. So factors of 49. There's a few of them, but I'll start with 7 and 7. And for 16, there's 4 and 4, and 8 and 2, and there's 1 and 16 as well. So I'll write down 4, 4, 8 and 2. I'm not going to reverse the order of 8 and 2, just because the 7, 7 that I recorded will give me the same thing when I crisscross. So let me try what I have so far. If this doesn't work, then I'll resort to the other factors. So the 4 and the 4 doesn't work because this is 28 and this is another 28. That's not going to give us the 70 that we want. So let's try the next one. 7 times 2, that's 14. And 7 times 8 is 56. So 14 and 56 will give us the 70. So when you're recording, just be careful that you remember that this has x, this has x, this has y, this has y, for it to factor. So we have our final answer of 7x plus 8y and 7x plus 2y. The last thing I want to discuss is the variable pattern that you have to double check before you begin, because not every trinomial does factor. So the first thing you want to always double check is that the first term and the last term have even powers on the variables, and the middle term has exponent of the same variables that you have in the front, but half of it, half of the exponent, and the same one as from the back, again half of that exponent. The reason for that is when you FOIL, you should be getting this middle term from outside terms multiplied and inside terms multiplied. So this one does work. So let us factor this by taking the factors of 20. I'll start with 4 and 5. There's other ones that will work. Also keep in mind this is like x with 3 and x with 3 here, which you don't have to record. Just remember to do that when you're recording the final answers. And then we have 42 could be 6 with 7. As I said before, I like to start with numbers that are close together. I'll also reverse the order. There's other combinations, but let me try these combinations before I go on. Oh, and once again, don't forget this could be with y squared, y squared. All right, so we want to crisscross and see if we can get negative 59. Because this is positive 42, we have to have two negatives to make that addition of a negative number. So we have 4 times 7. 4 times 7 is 28. And then we have a 30. 28 and 30, if both of them are negative, are not giving us the negative 59. So let's try the other combination. We have 24 and 35. 24 and 35, if both of them are negative, are the 59 that we want here. Alright, so we're going to record top with the top, 4x3 minus, because we wanted both of them to be negative, 7y squared, and then 5x3 minus 6y squared. The second last example, the variable pattern, if you look at it, it's actually not going to yield what we want. Let's say you didn't notice that, and you proceeded to try the combinations 1 and 1, 12 is 2 with 6. This will give you the 8 that you wish. So let's say you didn't notice and you proceeded to write down x squared plus 2y3, and then you'll have x squared plus 6y3. If you are to FOIL this, these two are going to be 6x squared y3, and then the inner ones will be plus 2x squared y3, which is 8x squared y3, but you do not have that y3 in the question. So you have to be careful before you even begin to look at the variable pattern. Alright, in our last question, I can pull out a common factor of 3x squared out, and I have x squared minus 4. You may recognize that this bracket here is a difference of squares, but the crisscross method actually works no matter what you have, and that's the reason why I like it. So I'm going to just rewrite this as just as an explanation. You don't have to do this, how the crisscross method works even with the difference of squares. So we have a combination of 1 and 1 for x squared, or 1x and 1x, and then we can have 2 and negative 2. When you crisscross negative 2x and then you have positive 2x, that's exactly the 0x that you would need. So final answer is 3x squared, x plus 2, x minus 2. I hope you found this helpful.